Okay, so let's use the trig identities that we just looked at to actually simplify very complicated looking trig expressions. Because it turns out that some of these real trig expressions that look sort of awful really can be sort of reduced down to something really, really simple. And these are just great fun because it's almost like puzzles. You know, you sort of have this awful looking thing and you got to massage and massage and massage until at the end of the day you can feel completely relaxed after massage and you have a nice small trig expression. Let me show you what I mean. Let's start off with this one. Now this may not look that threatening to you. Tangent x multiplied by cosine x. But let's see if we can actually make that thing look even better. So I want to just see if I can simplify this trig expression. Well, I can remember what tangent is. Tangent is just sine x over cosine x. So in fact, I could write this as sine x divided by cosine x. And then if I multiply that by cosine x, and then I see, oh, these cosines cancel. Now, of course, there's a little thing we shouldn't be too sloppy about. I can only cancel as long as cosine x isn't equal to 0. Now, there are a lot of places where cosine is 0. But as long as cosine is not 0, I can cancel. And I see this thing actually is the same thing as sine of x. So that's pretty cool. So tangent x cosine x is actually equal to sine x, as long as cosine x isn't 0. So you can see how I can simplify this thing in just one little thing like that. Let's try some more. I just love these things. I can do this for hours, by the way. 1 plus tangent squared theta divided by cosecant squared theta. Okay, what can you do here? Well, there's two ways to proceed here. If you're really, really sort of sharp and clever and with it, which, by the way, I am not, you could use the Pythagorean identity, which says 1 plus tangent squared theta equals secant squared theta. So you could just replace this whole thing by secant squared theta and start simplifying. I'll do that this one time. So the top, using one of those Pythagorean identities we talked about, is just secant squared theta. And then I divide that by cosecant squared theta. That looks like maybe that's the best we can do, but let's convert everything to sines and cosines. Because in fact, that's always the strategy I use, always. Because it's easier for me to know, I know everything about sines and cosines. There's nothing in the world that I don't know about sines and cosines. Well, there probably is, but I'm not going to tell you about them. Anyway, the point is, when I see tangent and cosecants and stuff like that, I usually convert them to sines and cosines. I'd write this as sine squared over cosine squared, and I'd write this as 1 over sine squared. So if I were to translate all these things into sines and cosines, what would I see? Well, secant squared is just the same thing as 1 over what? Well, it would be cosine squared theta. And cosecant squared is just 1 over sine squared theta. Now, you've got to be careful here. What happens when I invert and multiply? The 1 over sine squared becomes sine squared over 1. Whoop. So I see the sine squared on top and the cosine squared on the bottom. This is just sine squared theta over cosine squared theta. But that can be reduced even further, too, because what is sine over cosine? That's tangent. So this is just tangent squared. So this awful-looking thing, which has a tangent squared in there, actually just equals tangent squared. It's almost like amazing magic, isn't it? But just doing some very careful simplification using all the identities we know, we can actually write this complicated expression as a much easier expression to deal with. Neat. All right, one last one just for the road. 1 minus cosine squared t divided by sine t. Let's see if we can make this thing an easier expression. Well, when I see a 1 minus cosine squared t, the thing I think about is this identity right here. Let me show it to you. It's sine squared theta plus cosine squared theta equals 1. In fact, notice that if I take this cosine squared theta and bring it to the other side, I'll have a 1 minus cosine squared theta. So I see that 1 minus cosine squared theta is the same thing as sine squared theta. It's just this formula, this part, brought to the other side. Whoop. So this thing is just sine squared theta, or in our case, sine squared t. So again, using the Pythagorean identity, I see the top is just sine squared t over sine t. And I can cancel. Here I have sine. Remember what this means, by the way. This is sine t times sine t. That's what sine squared t means, over sine t. I could cancel one of these away. Again, there's a little proviso here. I have to make sure that the sine of t isn't 0. But as long as it's not 0, I can cancel. And what do I get? What I get is sine t. So look, this really complicated looking expression turns out to be the same thing as sine t. So it's really pretty cool. You can take some of these really awful looking things, and if they just sort of fit together just right, they can actually be simplified. It's a tremendous conspiracy, and you're left down just to something simple. Turns out these things will be very valuable and useful in sort of verifying certain identities and solving certain trig equations. So these techniques, even though they're not that difficult per se, I think are sort of fun and also really important. Okay, up next we'll take a look at some more identity type stuff.